and then scroll down here and choose the NAT gateway, then create that NAT gateway. Call it my NAT. Select the subnet where I want it to reside. I want it to reside in a public subnet because the public subnet is the only subnets that are enabled to get outside. So make sure to choose one of these public subnets. If you choose the private subnet, the NAT will not work because the benefits of the NAT is to translate our private IP address to a public IP address. So the outside will believe that we are connecting from the NAT, but in reality we are connecting from within the VPC. So it translates our private IP address to a public IP address. So choose public IP address, public subnet, and here I don't have no elastic IP address. An elastic IP address is a static IP address. It's not like the public IP address. The public IP address is dynamic. Once you stop your instance and you start it again, that IP address is changed. But for elastic IP address, it is once you allocate that IP address, it became for you. Then you will be in the charge of that IP address, either if you use it or not, but you will be in the charge of that elastic IP address because no one will be able to use that IP address soft you. So that is the difference between the elastic IP address and the dynamic IP address. So as long as I don't have already elastic IP address, I will allocate a new one for me. Then I will scroll down here and I will create my NAT. So once my NAT is created, I have to add that to my route tables. So go to private route table, scroll down here, and then edit routes. So any traffic that is destinated to the internet, go to the NAT gateway. Then save the change. We scroll down to check if my NAT gateway is available. So it's still in the pending state. So I have to wait until it will be in the active state so I can use it. So let me come here and refresh the page. So we'll pause the video until it be active. So now it is in the active state. Now it is available. So if I come back here to our master and try to ping google.com, now the pings work. We try to go to the other instance and ping google.com will work. And if we try to ping our Ansible server, so ping, now the ping work as well. This absolutely work fine. So what we have to do now is to install the dependencies on our masters node and as well on our worker node. So I have already created files for that. You have just to go to my projects on GitHub and scroll up here and to check the expand this folder, and we go to the nodes config. So here I have give you the steps how you can integrate your 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 master node with AWS, because even if we are running our master node and worker node on AWS, that does not mean that we can interact with the other resource. I mean interacting with the other resource that, for example, if I want my master node or my Kubernetes cluster be able to launch a classic load balancer on my behalf, because as you know, when you are dealing with services in Kubernetes, right, there are three types of services. There is cluster IP, and then node port, and load balancer. So you use the last one when you are in the cloud, and you use the others when you are in the local environment. So to to enable our clusters to interact with AWS, we have to give a special configuration for our cluster. They are not the same steps that we use or that we follow when when we want to configure QBDM in a simple way. But when we like to integrate our QBDM with the cloud provider, we have to follow different steps. So for now, I will use only the default way, and I will try to cover the other way as well. So first we'll copy this line to install the kubelet, kubedm, and the kubectl.